Now in this case we're going to use some music, the same piece of music, to drive the height of some boxes. So let's lay down a geometry node, which are going to be our boxes. Dive inside, and I'm going to lay down a line, and I'm going to take our line and make sure that we have 5 points on it, and we're going to have it going in the Z direction. Let's get rid of the grid so that we can see it a bit more clearly. And I'm going to add an attribute to our line, which I'm going to call height. And it'll start off with a value of 0, but we're going to see how to draw in its value in a moment. And then I'm going to have a box, and I'm going to take the box and I'm going to transform the top of the box. And the top of the box, if we have a look at the primitive numbers, the top of the box is polygon number 5. So if we apply the transform to number 5, that will ensure that the top of the box moves. And I'm going to lay down a copy SOP, and we're going to copy the boxes onto our line. I'm going to have to extend the length of our line to accommodate the boxes. There we go. So we've got 5 boxes, and we're going to use the transform as follows. We're going to use the stamp inputs, and we're going to call the first variable ht, and we're going to make it equivalent to height, and then we're going to translate in the y direction using that variable, which we can access using the stamp function. We're getting the variable from the copy node. It's called ht, and my default value is going to be 0. And that should mean that if I increase this value, our boxes all increase in height. Now we must bring in our music, but first of all I'm going to add a null here, which we're going to call height ref, and we're going to use that as the reference point for bringing some data into CHOPS. So let's now set up our CHOPS network, and again I'm going to call it music, lay down a file node, and access the wave file that we had earlier. And on this occasion I'm just going to lay down the pitch stop straight away as follows, and we're going to got 5 boxes, so we're going to divide it into 5, and I want to demonstrate a slightly different technique for lining up the names in a way which is sensible. So let's start by bringing in our height values, and I'm going to lay down a geometry chop, and this has 2 ways of operation, but first let's change our attribute to height and the rename scope to height, which means our channels will be called height, and let's choose our height ref null. and we can see something that's not very interesting because the values of height are 0. So I'm going to go back into our SOP network, and I'm going to change our attribute create so that each height value is different initially. And let's go into CHOPS again. Now what are we seeing here? We're seeing a number of different points. We've got a single channel height, and it's got a number of points. Well, what we've actually got here, though it says frames along the bottom axis, is a map of the value of our attribute height varying by the point number. So this is the value at point number 0, 1, 2, 3, 4, and so on. It's not exactly what we want. What we actually want is to bring in a different channel for each point. And we can do that by changing the method to animated. Now we've got 5 channels, height 0 to height 4. So what we want to do is to add, which we can do using a math SOP, we want to add the pitch information to the existing values of height. And we must get the inputs the right way around to ensure the names turn out as we want. And we can combine CHOPS, add. So we've now got our existing values of height added to the output of our pitch. And I'm going to stick a null on the end of this, which we'll call height out. Now the next step is to bring this information back into our geometry. Before I do that, I want to make one remark about the way CHOPS stores data. If we have a look at the music, we can see it's incredibly detailed. We've got really, really complex curves, so that even in half a frame you've got a very large number of variations in that curve. And yet, when we get to the pitch SOP, we can see that detail has been eliminated, even though we've got some high frequency pitches being analysed. So what's happening? Well, partly it's the effect of the pitch SOP itself, but partly it's to do with sampling rates. And we brought in our file here, and we didn't change the sampling rate. If we middle click, we can see that the sampling rate is 44,000 Hertz. So 44,000 samples per second, which is an enormously high frequency of samples. We get to our pitch SOP. If we have a look here at the channel tab, we can see that the sampling rate is 24. So it's taking 24 samples per second, which, since we have 24 frames per second at the moment, amounts to a sample every frame. And we can actually see the samples. If we right click somewhere here in the view, we can select dots, and we can see the samples that Houdini has taken. So it can be important to know what your sampling rate is if you want to deal with data which is varying at a rate greater than the frame rate. But in this case we can leave it at 24. And by the way, there's rarely any point in having a sampling rate that's greater than your frame rate when you put data out of CHOPS. So let's put the display flag on our height and look at how we can bring this information into our geometry. So let's go up to our geometry network, our SOP network, and we need to take our height values from our CHOP network somewhere here before it's fed into the copy node. And what we can use to do this is a channel SOP. So let's wire that in before our copy node. And it gives us an error because we haven't set the channel scope correctly. What this is essentially is a reverse of the geometry node that we used in the CHOP network. So we need it in the method to be animated. We need to find the height out null that we put into our CHOP network, and we need to give it the channel scope of height and the attribute as height as well. And we should find that our boxes are now adjusted by the music, and we can see that that is indeed happening. The frequency is a bit fast. We could calm that down by inserting an envelope chop as we did before here after the pitch. And that should ensure that our variations are kept more manageable. So that's how to vary geometry using chops and music.